Good morning, students. Today we will going to explain D'Alembert's theorem. It's a very important topic that you are supposed to study. In this session we are just explaining some fundamentals so that it will help you to understand about the things what is it. Let's start. D'Alembert's theorem can be defined as a dynamic analog to the principle of virtual work for the applied forces in the static system. What is virtual work? What is virtual work? Virtual work where the net force is zero. What is the net force? Suppose if it is a system and there is a lots of molecules are there, you may say particles are there. If this side there is a 6 kilonewton of forces and opposite side there is a equal and opposite 6 kilonewton of forces, then the system will remain in equilibrium. Okay. In principles of virtual work, we can explain in principle of virtual work d del w, that is the work done, equal to force into displacement. Okay, we assume that after applying the forces in a static system, the particles which are within the system are displaced a very small amount. Okay, this displacement is considered as a del Ri, which is sometimes known as a virtual displacement. Okay, work for virtual displacement is known as virtual work. So virtual work is defined as the work for virtual displacement is known as a virtual work. You should always remind that virtual displacement only happen due to applied forces, okay. Apart from the applied forces in the system, there is another forces which is known as constraint force. Constraint, okay, constraint force. What is constraint force? Constraint force is nothing but a force which is which makes limits the movement of particles in three dimensions. Suppose if it is a particle, it can move freely in three dimensions, x direction, y direction, as well as in z direction. But if in two dimensional system, if you able to move the particles in freely or you restrain the movement, then the applied force which is responsible to restrain its movement is known as a constraint force. Okay, for the system in motions, we are going to apply the static thing we are going to apply in the system which is a motion. So from the second law of Newton, we know Fi, that is the the force we written is dpi divided by dt, where p is the momentum and t is the time, rate of change of momentum with respect of time. In case of classical mathematics, time derivative is also expressed as p dot. Okay, so I written as pi and make the equation as 1. So from the virtual work equation, you can see here it is written as del w equal to summation of Fi into del Ry. Means all the forces acting in, why we put the summation? Because all the forces acting in that system. And now if you move this pi in this side, what will happen? You can see from equation 1, Fi minus p dot I equal to 0 from equation 1. Okay, follow the steps carefully, very carefully. And if there is a plenty of particles within the system, so we use the summation sign. Okay, summation I, what will be? Fi minus pi equal to 0 if del Ri is the virtual displacement. Okay, so what will be the equation? Will be Fi minus pi. Follow these. Now the displacement. What was the displacement? Dri. That is the very small amount of displacement. Okay. You know that I have explained that force is a two kind of, one is a applied force, another is a constraint force. Now we will going to write down the two forces in case of Fi. So what we will say? Fi as a applied force as well as Fi as a constraint force. Okay. Into del Ri equal to 0. Now you can see what will happen. Summation I, there was a pi. Okay. So Fi minus pi into del Ri plus Fi del Ri equal to 0. Now you know that Fi is a, due to Fi, which is known as a constant force, it has zero value because it doesn't have any kind of weightage in case of movement. So we can ignore this. So what will be equation will be? The equation will be, I'm just making it in this side. It will be like summation I, there will be F applied force. So what will be the Fi A, there was a P dot, you can see P dot I into del Ri equal to 0. Okay. Now the thing is that if we making this equation is more simpler form, and the displacement, you know, there is a very less displacement, then the equation is comes at Fi minus Pi equal to 0. And we are ignoring the superscript A, as because that A is applied force, and we are not going to mention what is applied force and constraint force, because it's clear now that constraint force doesn't have any impact on this D'Alembert theorem. So this equation is a D'Alembert theorem. Summation I Fi minus Pi equal to 0. What is a Fi? You know, Fi is the applied force, and what is a Pi? You know, Pi is this part, is a this part. Okay, thank you.